In this video, I'm going to explain about the next method of configuration of MPLS-TE tunnel. We call it semi-dynamic loose next hop. You know that in previous video, we learned about the semi-dynamic tunnel, but with exclude address method. Now we learn about the next type of semi-dynamic tunnels, loose next hop. First, let me to explain what is the usage of the loose next hop semi-dynamic tunnel, and then we can learn about the configuration of this method. As you can see in our scenario, we have four routers, router 1 to router 4. And we have two type of pass. First, blue pass, and second, the red pass. Assume that you want to send the traffic from the all links of red pass. Actually, if you have a traffic between the router 1 and router 4, you want to send them from one of these four links. Okay, how we can configure MPLS-TE tunnel that uses all of these links, red links. If you configure explicit route, it means that, for example, in router 1, you should configure next address 10.1.3.3. But with this configuration, the bottom pass will not use. And it means that I want to see a condition that when the gigabit 0 failed, the gigabit 02 use. Okay, and if the link between the, for example, router 3 and router 4 gigabit 02 interface failed, other interface will use. How we can configure it? If you configure dynamic method maybe chooses another pass. Actually, we want to define explicit pass, but in our explicit pass, we want to say you can use any of these two links, for example, the top red pass or bottom red pass to reach to the router 3. Or you can use each of these two links between the router 3 and router 4. It means that in this type of tunnel, we configure explicitly the pass that we want, but not a strict, actually explicit pass. We configure loose, actually explicit pass. What does it mean? For example, in R1, you can configure the explicit pass, but with loose next hop. Loose next hop means, for example, you configure next hop or next address router 3. But it is not important that we use the top red pass or bottom red pass. Only you need to reach to router 3. Each of these two links can be used. Or from router 3 to router 4, you can use each of these two red links. Okay, actually here we configure the next hop explicitly, but this next hop in most cases, for example, is the T router ID of the router 3. Means next address 192.168.2543. You can use each link you want. Okay, it is interesting. Here, as you can see, we have two blue and red pass, and I want to use red pass, and each of these links should be used. But don't forget, here I'm not talking about the load sharing. This is fault tolerance, because RSVP will reserve only one link. But if the top pass fails, the other pass can be used. Let me to show you how we can configure it. It is very easy. First, this is our text file again. In the first step 0 actually, IP address configuration and enabling interfaces on all routers, router 1 to router 4, and then IGP configuration. Here we use OSPF. About the ISIs also we have similar condition. I configured the step 0. Here we don't have any new topic. Because of that, let me go to step 1. Step 1 also is similar to the previous scenarios, and here we have only global MPLS traffic engineering configuration on router 1, router 2, router 3 and 4 with IPsec, MPLS traffic engineering tunnels, and MPLS label range command. Okay, because this is similar to previous scenario, only I copy the configuration of router 1. First we can start from router 1, and then router 2. IPsec is enabled by default, and we need to enable MPLS traffic engineering tunnels, and also optionally MPLS label range command. And after that, the router 3 again, this is the router 3's configuration. And the last router is the actually router 4. This is the router 4. And now we completed the step 1. Okay, let me go to actually step 2. IGP MPLS traffic engineering configuration on all routers. Again, here we don't have any new topic. You learned about them previously. Router OSPF1, MPLS traffic engineering area quad 0, and MPLS traffic engineering router ID loopback 0. Let me to copy this part of actually configuration on and paste it on the router 1, and then router 2, and then router 3, and finally router 4. Okay, until now we completed step 2. Next step is the step 3. In step 3, we need to configure MPLS traffic engineering on all interfaces, and also we need to enable RSVP. Let me to copy this configuration for R1. This is the router 1 with IP RSVP bandwidth and MPLS traffic engineering tunnels. We can configure it. This is the router 1, and after that router 2. Okay, and then the next router is the router 3. This is the router 3. We have 4 interfaces here, and then we can configure the router 4. This is our configuration until now. And after that, here until now we didn't see any new command. Okay, but in the next step, the most important step in this scenario, step 4, we need to configure tunnel interface on router 1 to router 4. Tunnel destination is 192.168.2.544. This is a semi-dynamic tunnel. And the type of this, actually the path of this tunnel is loose next hop. Okay, this is the first time you see this method. And after that, please use red links. First, you need to configure IP explicit path name command. This is not new for you because you configured this command on the explicit path method. But in this time, instead of next address and then IP address, you configure next address, then loose, and after that, the next hop. Let me to show you. Look at here. For example, in our scenario, in the router 1, I'm going to configure IP explicit path name, any name, for example, R3. You can also configure identifier, means IP explicit path identifier, okay? But here, until now, we configured only next address. But look at here, we have 2 options. Next address can be strictly configured or loose configured. And the default is strict, okay? Because of that, I'm going to configure next address loose, then, for example, router ID of router 3, 192.168.2.543. What does it mean? It is not important for me that how you can reach to this IP address, to this router ID, okay? Means you can use gigabit 01 or gigabit 02, but you need to reach to this. And after that, the next hop, actually address is next address loose, now 192.168.2.544. This is the router ID of router 4. Means you can reach to the router 3 from any path, and after that from router 3 to router 4 again from any path. That's it. And then you need to configure your tunnel. This is not new for you. Interface tunnel 0, IP unnumbered loopback 0, and then tunnel destination is 192.168.2.544, for example 4, and then tunnel mode is MPLS traffic engineering. And you know that tunnel MPLS traffic engineering path option can configure path option 1, here explicit, and the name of our explicit path is R3. Look at here, actually we configure explicit, but this is not a real explicit or totally explicit path. This is loose explicit or semi-dynamic. Why? Because it can choose the top path or bottom path. Okay, but we need to configure it with explicit name. You know that when you configure TE tunnel with some method, you need to steer traffic into the TE tunnel. But before this function, let me to show you the steps of our tunnel. Do show MPLS traffic engineering tunnels. As you can see, tunnel is up, and the path choose is from the 10313, means gigabit 02, as you can see, and after that router 3, then router 4. Now let me to shut down the gigabit 02. Interface gigabit 02, then shut down. Actually, we removed this interface. I'm going to show you that we will have the gigabit 01 as the next as the outgoing interface to show MPLS traffic engineering tunnels. As you can see, gigabit 01 now is using, and another label received. Previously we received label 300, now 301. It means that this is a new LSP or label switch pass, and we use the 10133. Okay, and now we can understand what is the meaning of loose next hop in compare with the actually a strict next hop. Then you can configure the next step in step 5. Okay, we need to configure a static route on router 1 to reach to quad 4. This is the quad 4, not quad 5. And the outgoing interface should configure as tunnel 0. I'm going to show you. Here in the router 1, we can configure IP. First, let me to enable the interface again, no shutdown. And then IP route quad 4. This is the loopback 1 of router 4. Quad 255, please use tunnel 0 and do show IP route static can show us that now we have this static route. Then you can use trace route command, then quad 4, and after that numeric. As you can see, traffic went to the router 3 from the 10133 next stop means the gigabit 01, and then reach to the router 4. Now assume that the gigabit 01 is failed. Okay, shut down, and after some second we expect to see that the next pass will be used, trace route quad 4 numeric. As you can see, traffic went to the 10313 means gigabit 02 after router 3. It means that it is working correctly. And after that, as a summary until now about the traffic engineering or MPLS-TE tunnels, we completed different pass options that are available for us. We learned about the explicit method. We learned about the dynamic method, and we learned about the semi-dynamic. Semi-dynamic with two methods. First, exclude address, and second, next hop, or we can say loose next hop. Okay, if you want to compare the semi-dynamic methods with explicit and dynamic, when you configure semi-dynamic, exclude semi-dynamic, you say, please don't use this, for example, IP address. What does it mean? It actually is more near to the dynamic. Why? Because we say only, please don't use this IP address, but you can find other paths yourself. But when you configure loose next hop, actually you say you can reach to the router 3 from each link that you have, for example. I think this is more near to the explicit method. But finally, as a result, as a summary, we can say semi-dynamic method is something between explicit and dynamic method. All right, now we completed the pass option, but you know that until now we used only static routing to steer traffic into our tunnel, but we have other methods that we will use and we will learn about them in future videos.